Hi Year 12. Some of you struggled with the exam question on the DF10 work last week, so I'm just going to explain it. So the compound GMV is a potential green fuel as it can be made from glucose and can be blended with petrol. And you're shown what GMV is. It doesn't matter if you haven't come across this molecule before, that's irrelevant, but this is testing your understanding of skeletal formulae. So the question I says, write an equation using molecular formulae for the complete combustion of GMV to carbon dioxide and water. So the first thing that you've got to do is change GMV from the skeletal formulae to the molecular formulae. So I'm going to do that now. So there's GMV. Now, what you've got to remember is every kink there is a carbon. So I'm just going to draw those on. I know it's not ideal, but I'm going to draw those carbons on. There's one, there's another, there's another, there's another, there's another. That's an oxygen. So we know we've got 1, 2, 3, 4, 5 carbons. We know we've got 2 oxygens, there's one there and there's one there. The hydrogens are a little bit trickier. That is where you've got to look around each carbon and just see how many bonds it's got. Remember, it can have 4, so it will bond to as many hydrogens as it can. So we're going to have 3 hydrogens there. This carbon here has 3 bonds coming out of it, 1, 2, 3. So we're going to have another hydrogen coming out there. This carbon has 2 bonds, we're getting a bit messy, but 2 hydrogens there. This carbon has 2 bonds, so we're going to have 2 hydrogens there. Can you see now why we use skeletal formulae? Because this is so much messier. Now this carbon has 1, 2, 3, 4 bonds coming out of it, so it's got no hydrogens attached to it. So if we then count the number of hydrogens, we've got 1, 2, 3, 4, 5, 6, 7, 8. So it's C5H8O2. The first thing that you're being asked to do is write an equation for the complete combustion of this. So complete combustion, you should know, is burning in the presence of oxygen. And when it completely combusts, it makes carbon dioxide and water. Okay, so always leave the oxygen to be the last thing that you balance for here. So in GMV, we've got 5 carbons, so that's going to make 5 carbon dioxides. We've got 8 hydrogens, so that's going to make 4 waters. Then count up your oxygens on this side. So I've got 4 here, and I've got 10 here, so that's 14. So I need 14 over here. Remembering that I've got 2 here, I need to get this up to 12, and I'm going to do that by putting a 6 in front of it. Okay, so the next question says, calculate the ratio of the masses of carbon dioxide produced by burning equal masses of GMV and hexane. Show all your working. So it helps that you've already got the equation here to work out the number of moles of carbon dioxide produced when you burn 1 mole of GMV, but you also need to work this out for hexane. Quite straightforward. Hexane C6H14. When you burn that, completely combust it, again you make CO2 and H2O. We are only interested in the carbon dioxide, but let's balance the whole thing because it's good practice. Hexane has 6 carbons in it, so it's going to produce 1 mole of hexane produces 6 moles of carbon dioxide. 14 hydrogens, so we're going to make 7 moles of water. And then this is nice to this one because there's no oxygen in the actual in the fuel there. So we've got 12 oxygens in the carbon dioxide, 7 oxygens in the water, so that's 7 plus 12 is 19. So this is going to be, I've not left enough space, 9.502, then it gets to 19. So if you have 5 moles, GMV, 1 mole of GMV produces 5 moles of carbon dioxide. Okay, so if we burn 1 mole of GMV, we are going to get 5 times 44, because that's the MR of carbon dioxide, is 44 grams of it if we started with 1 mole of GMV, which is 220 grams. If we start with 1 mole of hexane, C4H14, we make 6 moles of carbon dioxide. So we're going to get 6 times 44, which is 264 grams. Okay, now that's if we have 1 mole of each, but the question isn't asking us that. The question is asking us So the next thing you've got to do is work out, not for moles of the two fuels, but for the masses, because the question says, if I just go back to the question here, calculate the ratio of the masses of carbon dioxide produced by burning equal masses of GMV and hexane. So we're showing all our working as well. So GMV, 1 mole of it would have a mass. You'd have to multiply that by the MR. So working this out, you can see the answer in the mark scheme, but carbon, there's 5 carbons, each with a mass of 12, 8 hydrogens, mass of 1, and 2 oxygens, each with a mass of 16, which gives an MR of 100. Nice number. And then hexane, 6 hydrogens, 6 carbons, 14 hydrogens, that has an MR of 88. All right, so 1 mole of GMV would be 100 grams. 1 mole of 100 grams of GMV gives us 220 grams of carbon dioxide. So we're getting up to the ratio bit. And 1 mole of hexane would have a mass of 88 grams. That's just using moles and MR. And that would give us a mass of 264 grams of carbon dioxide. All right, so then what you've just got to do is do the ratio. So we're doing, I'll put this down the bottom, GMV to hexane. All right, so we get 220 grams from 100 grams of GMV. So 220 divided by 100. The ratio between GMV and hexane, we get 264 out of 88 grams there. All right, so our ratio, that would work down to be, I haven't got my calculator here, can't do it on my phone because I'm using my phone. When you work it through and have a little look at the mark scheme there, that gives you a 1 to 1.4. Hope that helps. If you've got any more questions, give me a shout.